Right. So, what was the class yesterday? What we were doing? Uh, we are discussing about the singly linked list, right? So today we'll go ahead with something called a circular singly linked list. Today's date 16th. Okay, I have to share the screen. Okay, can you view the screen? Is the screen visible?
Yeah.
Yes, sir.
Yeah. 16th April 2021. We are going to discuss today circular singly linked list. Okay, so what is circular singly linked list? In the singly linked list, we have, for example, this is the start, and this is the first node, and this is the second node, and this is the third node. Let us take, there are three nodes, and this is the last, and this is the start. Example 518221341862. Let us take, right? So what will happen in the circular link in the this one? It is the first one is 58282 is stored in the start pointer, and the last pointer is stored here in the 1862 in, that is stored in the last node address is stored in the last pointer, right? So the second node address, that is 2134, is stored here, and 1862 is stored here. And what is going to be here? For example, these are the values 10, 20, 30. Let us take, right? So what is stored in the last address pointer? Address pointer, that is the address field of the last node. It is always null. It was always null, right? Yes or no, everyone? What is stored in the last this one? Please speak out. What is stored here in the last this one? It is the, yes,
Null.
null value. Everybody, please speak out. It is what?
Null
Unmute.
value.
Null
Null.
value,
Null
right?
value.
Null
Now,
value.
what we are doing in the circular single linked list is we are connecting from here. We are connecting it to the first node. So, like for example, there are 10 students, those who are gone to the excursion. First fellow is staying in one room number and is remembering second student room. Remember, second student is remembering third, fourth is remembering fifth is remembering sixth is remembering seventh is remembering eighth is remembering ninth is remembering the 10th student room number. But 10th is not remembering any of the this one since he is the last student. So instead of his address field having null value, let him remember the first student room number. Let him remember the first student room number. That means here also the last node which is there, the address field of this is null. It is null. Instead of null, what you do is let him remember the address of the first node. What is the address of the first node? 585182. So I'll write it as 5182. So what will be done is now there is a link established back. This is what is a circular linked list. That means the last node is going to have the address of the first node. So in normal singly linked list, the address field of the last node is null, is null, whereas in circular singly linked list, the address field of the last node is not null but it stores the address of the first node. Address of the first node. Is this clear what I have written? Yes, everyone. This is what is called as a circular linked list. Now, now let us write one by one the program, the same thing, the program for our circular linked list. Okay, so the first one, let us instead of S list, you call it as C list. Okay, what is that? Hash include stdio.h and all whatever is included. Okay, now struct type def, sorry, type def struct, I call it as C list circular, right? And what are the this one? First is int data, there is no doubt in that. Second one is also same. What is that? Struct C list star ptr. Okay, and what is, let us call this as same node, it would be easier for us. So whatever you are going to write now, node is going to replace struct C list. Everything is same. Type def. Okay. Type def. Okay. Right. Now this is what, and after this, what are the declarations you have? Node star start is equal to null, global declaration, comma last star last. Okay, these, and then what are the declarations you have? Int n is equal to 0, same. And now declare the functions void create, same, void insert, void next is delete, and void you call display or traverse or whatever. So these are the various functions you have. Now you'll go for the void main. Okay, the same thing, everything is same. Only thing is that now let us see how does the logic will change in the insertion and in the deletion and in the what is that called, in the display, how does it change in the create. Okay, that's what we will see. Okay, right. So is this clear? Can I, I'll go for the next this one, next page. You made a note
Sir,
on
one
this?
second. One second.
Yes, yes, everything is same as the say single linked list what we have done. Okay, how does the logic change here we will see. Okay, how does the logic changes we will see, huh? So your main function is going to be same, mama. A void main is same as a singular linked list. There is no change in the void main. So I'm not going to write. Void main is same. Void main is same as singular linked list. Close. Right. Now let us go for the next is what? What is it? We'll go for one by one creation. How to create a circular linked list? How to create right? So this we'll do it now. Huh? Now tell me when is the circular single linked list is empty? When is the circular linked list is empty? When same start is equal to null.
Null.
So the same thing I'll apply. I'll say that when start is equal to null, okay, the circular singly linked list is empty. Is empty. If it is empty, then the first node added, how you are going to add? Now this is empty, for example. Okay, start, this is null, and last is there, which is garbage address. Why? Because you have not inserted any node. Okay, so I'm inserting the first node now. Because it is empty, it becomes the first node. Yes or no? It becomes the first node. So let us take it is new node. Okay, which is at 3826. 3826. So what will happen now? This null value has to be replaced with 3826. Yes or no? Null value has to be replaced with 3826, and last value also should be replaced with 3826. 3826. Yes or no? Right? So now what has happened? You have established the link. This link has been established. But remember, what is to be done? This is cannot be null. This cannot be what? This is actually null, right? When the new node got created, but it cannot be null. What it has to be? It has to store the first node address, and this itself is the first node address. This itself is the first node address. So what does it store now here? What does it store? Tell me. It stores 3826 only. It stores 3826 only, right? So this is the first case when start is equal to null. The circular singly linked list is the first node. How it does. Now let us assume that it is not the it is not empty. It is not empty. Okay, not empty. When it is not empty, we are going to add it as a last node. Remember, always in the creation it gets added as a uh, insertion is different, creation is different. Okay, in the creation, in the first, if it is the first node, it will be treated as the first node addition. Otherwise rest all nodes are added as the last nodes. For example, let us assume, I'll draw the figure for you. Let us take this start. There is one node, there is another node. Okay, let us take that this is the last. Okay, this is at 3826 and this is 2134. Now tell me, what are the values of start? Come on, this is 10 and this is 20. Come on, tell me, what is going to be stored? Everyone please unmute and tell what is start value.
3826.
3826.
Good.
3826.
And what is last value?
2134.
2134. Perfect. Good. What is the value which is going to be stored in node 1 address field? What is going to be stored?
2134.
2134.
134. Yeah, what would be the last node? This is node 2 is the last node. What would be stored in this address field? Tell me.
3826.
3826.
3826. Is the diagram clear?
Yes, sir.
Yes, sir.
Right. Now we are inserting a new node. Not inserting, we have got a new node, which is at 5326. Let us take. This is new node. This is new node. Please understand everyone, right? Okay. Right. Now new node. Tell me in this, when this comes, this is null. Remember, this is null. We have this is, for example, 30. Now what is required to be done? This link has to be established. This link has to be established. Yes or no? Yes or no? Tell me, is this correct or not? The and this link has to be broken and this link has to establish. Yes or no? And then this link has to be broken and establish the link like this. I'm drawing the dotted lines. Is this clear? Everyone, can you see? So I have to now, what is the link which has to be established is last value changes. Last is nothing but new node. Got it or not? And what is this particular the node going to be accessed as? Now tell me, how am I going to access this address part? Can you tell me what is this address part? How to access this address part? Last arrow last arrow PTR. Everybody agree or not? Last arrow PTR should be assigned what value? New node has to be assigned. So this is going to change 5326. Okay, right? And then this 2134 changes as 5326. That is last is equal to new node. And there is one more, this one. New node arrow, new node arrow PTR should be equal to what? This 3826, right? So what is 3826? It is nothing but start. So 3826. So there are three steps which is going to be very, very important. One is, the first one is 3826. This you have to overwrite. That is last arrow PTR is equal to new node. Next, very important. Tell me, what is the next one? Last is equal to new node. That is, this is the first one. This is being overwritten. Next, I'm writing with this overwritten. Last is equal to, right? It is becoming the this becomes the last node, and then new node arrow PTR is equal to new node arrow PTR is nothing but three. This value 3826, right? So 3826 is stored in start is equal to start. Is this order clear or not? Right? And okay, this was now when it was as a first node, tell me how it is going to be. Start is equal to new node, last is equal to new node, and what is this is going to be, either you may say start arrow new, or you say new node arrow PTR is equal to start. Start. Very important. You need to be very clear. After giving start is equal to new node, then last is equal to new node, and new node arrow PTR is equal to start. Right? So this is how you are going to make the change. Is this clear? So now, what is the difference between this particular, this one and this one? This is as a last node, this is the first node, right? So that is the reason start is equal to value changes. But in this case, the start value does not change. In this case, the start value changes, and last is always new node. Here also you see last is equal to new node. Here also see last is equal to new node. Here also you see new node arrow PTR is equal to start. Here also it is new node arrow PTR is equal to start. But only difference is here, if it is the first node, it is start is equal to new node. If it is not the first node, last node, then last arrow PTR. This is identified by last arrow PTR. Last arrow PTR is equal to new node. Is this clear? The linked list, circular linked list insertion, insertion. What is this? This is creation. Is the creation clear or not? Can you write the program for this? Say everything same as that one? Yes. Can you write or not? Everyone, can you write or not? I want you people to answer whether you first of all take out your single linked list, right? So should we go back and see what is a single linked list? This one, which is we have written. I'll show you. This was your start, right? Okay, list is empty. Okay, so the program, this was all we have discussed, and then yeah, this was the main program. This is the same main insert. Why this is insert? Sorry, we have to take okay, enter your choice, case one, right? This was an example we are given. Let us create program. Where was create? This is insert. This is deletion. This is delete. This was this is weight. For operations, create a linked list. This was create. This was the main program, right? Yeah, this was what we have seen. Is it insert? Okay, did we write the create program? Everyone? I'm not finding here. Yes, Saiteja?
Yes, sir.
Okay, I'm not finding here. I'm only seeing the advantages of array. This don't know where. Okay, you have everyone. Please take out your this one. Create. You are anyhow going to write today also the this one.
9th April, sir. Void create program 9th April.
9th April. 4 operations. Create. Then this is a list. Create. Okay. Then enter your choice. Yeah. After this, I'm finding only uh, 9th April. That is missed out. I don't know. I think it was not saved. That create was not saved. Directly we came on to 10th afterwards. Okay. So I'm not finding it. Okay. Right. So doesn't matter. Let us take the create this one. What was the first step in create? Everybody have the notes now. Okay. Let us go to the this one. Create. What was the first step? Do you require a temporary new node, right? Okay. So create. Let us void create. Okay. Yeah. You require node star new node. You require. That's all. You don't require a temp or otherwise. Okay. Right. And what else you require? Tell me here. You require int val
Int
val.
value char
Char C,
Then
char C, sir.
char
C,
C.
sir.
Yes,
The
char
char,
c, char c we have taken.
yes, sir.
Okay.
Then do while loop.
Yeah. Do. Yeah. Come on. Tell me. First step is what in the do.
Printf,
Printf.
enter the data.
Printf. Enter data. Enter data. Okay. Scanf.
Percentile D, ampersand value.
Yeah. Good. Ampersand value. And after that, next is what? Malloc
New
function.
node equal to
Yeah. New
node
node.
into malloc into size
New
of
node is equal to node star
malloc
malloc
into size
size
of node.
size of node. So this creates a node. Okay. Now after this, what we have done? We are allocating new node arrow data. You are assigning value
Values.
and new node
Node star
arrow
PTR.
ptr. We are assigning null.
No, null.
Okay. Right. After this, now you are checking for if start is equal to null, then it is empty. Then it is empty. Okay. So what is the steps I have written now? If start is equal to null, what are the steps? Tell me. What
Not
is
equals to new node.
yeah, good. Start is equal to new node.
Last equals to new node.
Yes, last is equal to new node, and it
New
is
node arrow.
ah.
New arrow
This was
PTR.
only circular linked list. Only sorry, normal linked list. Only these two steps were there. Yes or no?
Yes,
Did
sir.
you is your notes having? You are keeping the notes with you?
Yes,
Did you
sir.
Yes, sir,
check it?
that is last step.
Okay, this is the last step. Now we'll have one more step. You have to assign the last node address part. You have to assign the first node. What is the last node address part? It is always accessed as last arrow PTR is equal to what is the first node address? First node is address is always stored in start. Is this clear? So that it becomes a circular linked list. Over. Else part, tell me now. What is else part? Else part, it is not the else part, it is not the first node. So I have told you how to access that this one. You have to change the last arrow PTR should be equal to new node, and then last change it as equal to new node. This is very important. Don't put last is equal to new node and after last arrow PTR is equal to new node. Then that will be a problem. You are losing the link. First, last arrow PTR, you put it as new node so that the new node is attached to the last, and now change the last node. The new node becomes the last node. So last is equal to new node. And after this, what is important? Again, you have to change the, what is that called? The how to access the this one. Now tell me, what are the steps involved? The
New node arrow PTR.
yes, new node arrow PTR. Okay, new node, or it can be last arrow PTR also, because you have changed, na? You have changed, right? Yes or no? You have changed. Last is been changed, na? Last is now new node, so you can write it as last arrow PTR is equal to new node also. That sorry, is equal to start.
Start, sir.
Is equal to start. Is this clear? That's all. After this, n plus plus.
Sir,
Yeah. Any doubt?
sir, can you say once again that if start equals to last step, sir, last arrow PTR equals
Yeah.
to start.
What is now first step? Last arrow PTR. When
In the
you,
if statement, sir.
huh?
In the if, sir.
If statement, if start is equal to null, it is empty. It is empty. I will go back. This, if start is equal to, if start is equal to null, it is empty. This is empty. So this node which has come up has to be attached to the first node as a start node in the link to the first and as well as last, right? But so what you are giving, the new node address is 3826. 3826 is overwriting the null, and as well as 3826 is overwriting the garbage address of last. Okay, so the link has been established. However, this particular what is that called? This particular last node which is now there, this address part should be the start. Should be always the start. So we are saying start is equal to new node, last is equal to new node, and new node arrow PTR, or we can say it as last arrow PTR. Both are same. New node arrow PTR or last arrow PTR. So that's the reason I've written new node arrow PTR, but in the program I've written as last arrow PTR. Same thing when it has to be added as a last node. Now, when the already nodes are existing, then start is not equal to null. Then it goes to the else part. It has to be added as the last node. When it has to be added as the last node, first of all, this was the last node. This last node address part, whatever is there, has to be overwritten with the new node address. That is 5326 has to come here. So how to access this particular address part? It is last, before new node is being inserted as the last node, it is accessed as last arrow PTR. Last arrow PTR is equal to new node, and after that last you change it as equal to new node, again 532. Now this particular address part you have to insert start address, because it is null, you have to override with start address. So how to access this? You can access it as new node arrow PTR, or you can access as last arrow PTR. Both are one and the same, because last is already storing 5326. New
Okay.
node is also 5326. It is either new node arrow PTR or last arrow PTR. So that arrow PTR is equal to start value you are putting it. Is this clear? So that is what we have written here. You see, first if start is equal to null, start is new node, last is new node. Both are the same steps as single linked list. Only difference is the last arrow PTR is equal to start. Similarly here, last arrow PTR was equal to new node, last is equal to new node. That was same, but we are having one more step. What is that? Last arrow PTR is equal to start. Is this clear now? And now what is the next step you are supposed to do? Tell me, right? continuation of this, very simple. We have to, what are the next two steps? Tell me, you have already done. What is the next step? Would you like to continue? N plus plus, you do it, and then you continue with the this one. So we'll go for the next page. Okay. So the next page, first step is, because one node is added n plus plus, then I'll say printf like to continue y oblique n. So std, right, f flush stdin, and then scanf percentile c ampersand c, we are storing it, and then close the do while c is equal to y or c is equal to capital Y, and then close the main void create. Is this program clear, everyone?
Yes, sir.
Is the function clear or not, everyone? Okay. So continuation of this. Now next is how to insert. Insertion. Now let us take insertion in of node in circular singly linked list. Okay, first step is case one is what? Now tell me, when CSLL is empty.
Empty, sir.
When it is empty, right?
Start equals
If start is equal to null. So you know how to do that. Start is equal to null means what is required to be done, right? That is case one. Case two, when position is given as equal to 1. When position is given as equal to 1. Okay, right? Now let us see, when the position is given as equal to 1, how the changes take place. This is start. This is the first node. This is the second node. And this is the third node. And this is the last pointer. This is a 3182. This is 2186. And this is 4822. Okay. So tell me, this is 4822. Yes or no? And this is 2186. And what is this? Now tell me, 3182. And what is this value? It is circular linked list, right? So what is this? Tell me now. Yeah. What is this value? 4822. And this is also 4822. Is this clear or not, everyone? Diagram. Now we are inserting at the pos is equal to 1. That means I have to insert in the first node position. For example, this is new node, and this is at 2832. 2832. Now tell me, this link has to be broken, and I have to establish the link here. Yes or no? Everybody agree or not?
yes, sir.
Right? And also remember, this is not the first node now, right? This link has to be broken, and this link has to be established. Everybody agree or not?
Yes, sir.
Yes or no? Right.
Yes, sir.
Now, so this particular 2832 has to be overwritten here. And remember, this 4822 has to be has to come here. Null has to be overwritten. And also this 4822 which is there has to be overwritten with 2832. Do you agree or not? Yes or
Yes,
no?
sir.
So there are three steps involved. One is first is the uh, start has to be overwritten. The start has to be overwritten with the new node address. New node arrow PTR should be written with the first node address. and also last arrow PTR should be written with the new node address. But if I override the first start itself is overwritten, then I'm losing this address. So what I am supposed to do first?
Temporary.
First new node arrow PTR, assign it as equal to start. So new node arrow PTR is equal to start. I'll do, so that the first node address, which is the previously first node which is there, address is being stored in new node arrow PTR. Now you change start as equal to new node. So what will happen now? Start will overwrite with the new node. Establish it. This established as a first node, and since the first node is having the address of this previous first node address is being stored, establish it. So the link is established. Now these two steps are same as your previous this one. Are you getting the point or not? Same as single linked list. But now the problem here is I want this particular last arrow PTR, however is there. This last arrow PTR has to be is to right now the first node address. Which is the first node now? New node is the first node. So how it is going to come up now? Last arrow PTR is equal to new node. Is this clear now, everyone? Is the insertion of node in the as a position is equal to 1 clear for everyone?
Yes, sir.
Everyone please check once again. First we are going to overwrite the new node arrow PTR. We will establish the link between the new node and the previous first node, whatever was there, right? This first node address. So first node address is 4822, that is stored in start. So start value, assign it to new node arrow PTR, new node arrow PTR. Now establish the link between the start and the first node. So start is equal to overwrite with the new node. So start is equal to new node. And afterwards establish the link between the last node PTR, whatever is there, establish with the new node, which has become the first node. So where is how to access this last node address part? It is last arrow PTR, assign new node, last arrow PTR assign. So this is how you it becomes pos is equal to 1. Okay, that is the this one. Now let us go for the next case. What is the next case? Now
Pos
tell me.
equals to n.
Just tell me. Now the next case 3. What is the case 3? Now tell me. If pos is equal to the
n.
insertion of node as last node, as last, that is when pos is equal to tell me, is it n or greater than n?
N, sir.
Oi, when pos is equal, there are 10 nodes. You have to insert it as the 10th node. What will happen? 10th node will become 11th node or not? So what is, please go back to your linked list, this one. When the pos is greater than n, when pos is greater than n, not greater than or equal to also. For example, there are 10 nodes. I want to insert as the 11th node, then it becomes the last node. If I want to insert as the 12th node also, it becomes the last node. If I want, if there are 10 nodes and I want to insert it as the 10th node, what will happen? 10th node will become the 11th node. Yes or no? Yes. So then how can you this one? So insertion of node as the last node, that is when pos is greater than n. When pos is greater than n. So when pos is greater than n, let us see. This is start. This is the first node. This is the second node. For example, this is the third node. And this is last. So this is 3862, 4826, 5182. So this is 5182, and this is also 5182 to establish the link between this, and this is 4826, and this is 3862, and this is 3862. Is the diagram clear? Right, now we are inserting as a last node. So for example, this is at 4922. This is a new node. So what will happen? This has to be overwritten with 4922. So the link has to be established. Okay, got it or not? Right? And this has to be overwritten with what now? This has to be overwritten with 4922. 4922. Got it or not? So that the link is established. Okay, and what is this? This was null. Null is to be overwritten with what now? First node address
5182, sir.
5182.
82.
So this has to be, is the diagram clear now for everyone? Okay, so this is what is a diagram which is going to come up. So now tell me, if it has to be inserted at the last node, what are the steps which has to be followed? First of all, this particular how are we accessing this node? How are we accessing this node? This is the last node. Before insertion, this is the last node. So it is last arrow PTR. Should be equal to what? New node. Should be equal to new node. But what is written here? It is a start value is written. Start, the first node address is available. That's not a problem. Then last, what is the last is equal to new node. And how to access the this one last arrow PTR should be equal to start.
Start.
So very simple. First is what? I'll say last arrow PTR is equal to new node is the first step. Okay. Then I'll say last is equal to new node, and then new node arrow PTR or last arrow PTR, both are one and the same. Why? Because already last has been assigned the new node. Last arrow PTR is equal to start. Is this clear? How it becomes a last node? This is the same as your circular linked list, that insertion of the last node what we have written already. If position is greater than n. Now only in between node. In between node, is there going to be any change in the this one? Tell me. In between node in
No, sir.
circular linked list or single
Single
linked
node.
list, is there any change in between node?
No, sir.
In between node there is no change.
Only last node.
Case 4, I'll say insertion of node in between any two nodes, right? It is same as insertion of node, right, in a singly linked list. That's all. Is this clear? Is it difficult insertion, everyone? So can we write the program of the insertion now? Okay, take out your singly linked list program. Everyone, please take out your singly linked list program. Singly linked list, what is the program I am telling you? Please take out your what program? The function insert. The function insert. Insert function. Function insert, that is void insert. Yeah, what is that you require here? Tell me now in insert. Yes,
Node
everybody.
star. Node star
Node
new node.
star new node is
New node.
required, and
Start
also
temp.
start temp is required for us. Okay, and then int value is required, and also I is required. I is required. Anything else required now? Tell me other than this. Yeah, please check your
No,
insert.
sir. No, sir. That's
Same
all.
thing. Now again,
Character, sir.
char C
C.
do. Yeah. First is what? Tell me, everyone. Printf. Enter.
Enter values.
Enter data. Store it where? Percentile D ampersand.
Ampersand value.
Value.
Okay, good. And afterwards, new
New
node.
node equals to malloc function.
Yes, new node is equal to node
Node star
star
malloc.
malloc of size of node. Okay, done. After this, new node arrow data is equal to value, and new node arrow ptr is equal to null. Okay, all these steps are over. Now what will happen? Tell me. You ask for the position. Printf, pause is missing. That's the reason I have asked. Pause. Pause is missing. Okay. So printf, enter the position. Enter the position. Scanf, %d, ampersand pause. Now if pause, if start is equal to null, first case, what is start is equal to null? Tell me. We have already written. Come on, fatafat, you should tell. What is the start is equal to null means? We have already written in the create function. Tell me the steps, 3
Start
steps.
equals to new node.
Yes, fatafat. Start is equal to new node.
Last equals to new node.
Last is equal to new node.
Last arrow ptr equals to start.
Last arrow ptr is equal to start. Okay. This is what is the case of what? If start is equal to null. Now let us go for the next, this one. What is that? What is next? Else part. Else if pause is equal to 1. If pause is equal to 1. Now tell me, if pause is equal to 1, what will happen? This is the first node. How to insert it as a first node? Come on, tell me, fatafat. How to insert it as a first node? Yes, the steps. What is the first node? I've just written, na? What is the
New
first
node
node?
arrow PTR is equal to start.
New node first. Good. New node arrow ptr is equal to start. And then,
Start is equal to new node.
yeah, start is equal to new node. Very important. Next.
Last arrow PTR is equal
Yes,
to
last arrow ptr is equal to start. So this is what is pause is equal to 1. Else now if pause is greater than n, we'll say, right? Greater than n. Tell me, greater than n, it is last node. So how to do that? Last arrow ptr is equal to
new node.
new node. Then last is equal to new node. And then last arrow ptr is equal to start. This is what is the position greater than n, that is the last node. Now the else part is what? It is the else part is what? Now tell me. It is the, it is what? It is the last it is in between node. In between node we have to take a temp, right? So go back to your singly linked list. How did we do that? First initialize the temp is equal, I is equal to how much? I is equal to
1.
1. Yeah. And then initialize the temp is equal to what?
Start.
Start. Good. Yeah. Next what happened?
While I less
Yes.
than pause.
While I less than pause, what did we do? Temp is equal to temp
Temp arrow
arrow
PTR.
ptr, and
I
then what?
plus.
I plus plus. After this, what did we do? Tell me.
New node arrow PTR is
Yes,
equal to
very
temp arrow.
simple. New node arrow ptr is equal to new
Temp
node
arrow
arrow.
PTR.
Yes, temp arrow ptr. Then
Temp arrow PTR is equal to new node.
temp arrow ptr is equal to new node. Okay. Any other step? That's all. These are the steps involved. Okay. This else is closed. Else is closed. So after this, what are we going to do? N plus plus, and would you like to continue? Okay. So after this, we are going to do N plus plus, and then printf Like to continue? Y oblique n slash n scanf. Sorry, if that f flush stdin. If you don't want to use f flush, then use scanf percentile s. Percentile s, if you use, you will not have a problem. Percentile s, and you use it as ampersand ch, it will work. Okay. Then scanf percentile c ampersand c. Okay. And then close this, and while c is equal to y, or c is equal to capital Y, close, and then this is what is a create, insert. Okay. So if you want, you can make a note of the program. So everyone, if you want, you can make a note. So this is what create. Everyone had made a note of the create program. Create. Everyone,
Yes,
please
sir.
make it. Yes, I think everyone has done create. Now we are talking of this one. You please make a note, everyone. Case one is very clear. Case two. So this is case three and case four. Did you make a note of the notes or not, everyone?
Yes,
So
sir.
please
Yes,
make a
sir.
note of the one, right, insertion of node in circular singly linked list when CSLL is empty, if start is equal to null. Okay, then when pause is equal to 1, so this is what. Okay, and then please make a note, case 3, insertion of node, last node, when pause is greater than n. When pause is greater than n, so this is what you're going to do. And then case 4, insertion of node in between any two nodes, it is same as insertion of node in SSL. So this is what is insert program. Okay, you can make a note of the insert function. And today I want you people to complete the SSL, and also if possible both void insert and create of a circular linked list also, you can do it. Complete it. Made a note, everyone? Should we go for the next slide? Everyone unmute and say yes. Any no means I'll stop.
Yes, sir. Next slide.
Yes, sir.
Yes, sir. Yes, sir.
Good. Then let us go to the next to this one. L pass is equal to 1. Else if pass is greater than n, and else is as the insertion. So please make a note of this. Everyone done? Can make use of technology. You can take the screenshot and or print screen and store it in the if you are using computer laptops, print screen and open a Microsoft Word document and paste it there, and afterwards you can enlarge it and you can have it as a notes also. Okay, don't use
Yep.
mobiles is not correct. Okay, so this is what is the final, right? So this is the end of today's class, and tomorrow don't miss out. Tomorrow I'm going to complete the circular single linked list. Very simple is how we are going to delete the this one deletion we are going to see, and as well as print. Okay. Let Let us see the attendance, please. Have you? I have forgotten to make the host, co-host. It is a responsibility of Karthik and Nandini. You people have to tell me immediately once we start off the class. You people have to tell me to what is that called? Make you people as co-host. Is this clear, Karthik?
Yes, sir.
Yes.
I thought to ask, but you will scold in fear again.
No, no. In the starting itself, you can say that. Okay.
Okay, sir.
Yes, sir.
All right. And before this, I'll stop recording. Stop recording.